My first C++ Qt program and my thoughts on it. January 15, 2023. Today, I am going to introduce the first C++ Qt program that I have ever created. As there is no standard built-in GUI library for C++, it is necessary to install a certain GUI library for C++ before building desktop applications in C++. The designer of C++, Bjarne Stroustrup, acknowledges in the FAQ section on his homepage that C++ has many commercial and open source GUIs such as Qt, but it does not have a standard GUI. As Qt is arguably one of the best GUI frameworks for C++, I decided to give it a go. The objective of this program is to display 4 types of GUI components of varying colors, fonts, positions and sizes in a window. Before expounding the syntactic details of this program, I am going to introduce the prerequisite for creating any Qt program, namely Qt Creator. I am also going to compare a number of differences between Qt widgets and Swing components. Before creating any Qt program, it is essential to download Qt Creator by clicking the download button at the link https://www.qt.io/download-qt-installer, and then install Qt Creator by running the downloaded executable file. The installation of Qt Creator is divided into several steps. I found out that one of the most important steps for installing Qt Creator is to check the checkbox labeled with the supplementary text MinGW toolchain and Qt libraries for MinGW during installation folder. If Qt Creator is installed with this checkbox left unchecked, the error "No suitable kits found" might occur in kit selection while setting up a Qt widgets application after clicking Create Project. In Qt Creator, if this error occurs, the next button in Kits is also grayed out and it would not be possible to proceed to Summary and set up a Qt widgets application subsequently. After a Qt widgets application is set up in Qt Creator, the following code snippet is automatically generated and displayed in the editor. Next, I am going to explain a few programming concepts involved in this code snippet, in my own words. #include main window.h, #include int main int argv, char argv, application argv, argv, main window w.show, return a.exec. The header file named main window.h is necessary for declaring the main window object w. It turns out that it is also possible to create a window resembling main window object w by declaring a frame object, which is equivalent to a frame object in Java Swing. The Qt widget class application is said to manage the control flow and main settings of a GUI application. As far as I am concerned, as there seems to be no need to declare an object for the application itself in Java, application does not seem to be equivalent to any Swing component. The main method returns an int value and contains 2 parameters. The first parameter is an int variable argv, which is said to stand for argument count. The second parameter is an array of pointers to characters argv, which is said to stand for argument vector. In the body of the main method, an application object named A is declared with the 2 parameters mentioned above. A main window object W is declared. As the show method is invoked for W, the window is shown when the program is compiled and run. The exec method is said to enter the main event loop and wait until exit is invoked. In order to prevent the window from disappearing instantly, the exec method is invoked for A, which is then returned at the end of the body of the main method. The code snippet of my first C++ Qt program not only retains all the features of the code snippet mentioned above, but also involves a lot of unique ones that I have never touched upon before. In the beginning of the properly formatted code snippet of this program, the header file main window.h and 5 Qt widget classes were included. In the beginning of the body of method main, 2 statements were automatically generated. A application object with the parameters of argument count and argument vector, as well as a main window object w were automatically declared. Next, I declared an array of checkbox objects, an array of global objects, an array of push button objects and an array of creatio button objects, with each array with a length of 2. The syntax for declaring an array of any Qt widgets differs from that of declaring an array of any Swing components. It turns out that there is no need to type the new keyword to instantiate an array of Qt widgets or even just Qt widgets. The syntax of declaring an array of any Qt widget is simple. The first step is to type the name of the Qt widget class. The second step is to define the name of the array, whereas the last step is to type an integer, which indicates the length of the array, bracketed by square brackets. Using this syntax, I declared an array for each of the 4 Qt widgets. As the names suggest, certain Qt widget classes are somehow equivalent to their corresponding swing classes respectively. For instance, Kickbox is equivalent to Kickbox, Global is equivalent to Global, whereas Radio Button is equivalent to Radio Button. Additionally, it seems that Push Button is equivalent to Button, though I found out that it was only possible to click a push button object when the cursor was hovered over its left part. Nevertheless, there are multiple striking differences between any of these Qt widget classes and their swing counterparts. Firstly, it is possible to invoke methods on any Qt widget without instantiating it with the new keyword, but it is necessary to instantiate a swing component with the new keyword before invoking methods on it. In fact, attempting to instantiate a Qt widget by using the syntax of instantiating a swing component turns out to result in the error of no viable conversion from widget name to widget name. Secondly, methods of any of these Qt widget classes differ considerably from those of their swing counterparts. For instance, the setStyleSheet method can be invoked on Qt widget classes, but not on their swing counterparts, whereas the setBounce method can be invoked on swing components, but not on their Qt counterparts. Thirdly, the method for adding a Qt widget to the main window object is exactly opposite of the method for adding a swing component to a frame object. To add a Qt widget to the main window object, the setParent method should be invoked on a Qt widget, in contrast to the add method being invoked on the frame object. The setParent method is reminiscent of the parameter parent component, which is passed to certain methods in the JOption pane class. Nevertheless, it should be noted that instead of the defined name of the container, the reference of the container should be passed to the setParent method. The reference declarator as well as the address operator denoted by ampersand is used to declare a reference variable. Therefore, it is possible to reference the container by typing followed by the defined name of the container. After declaring an array of a length of 2 for each of the 4 Qt widget classes, I invoked the methods move, setFont, setStyleSheet as well as setText on each of the 8 Qt widgets. To a certain extent, the move method invoked on Qt widgets is similar to the setLocation method invoked on swing components. In fact, it turns out that the move method can also be invoked on swing components, albeit a deprecated one. It seems that this deprecated method serves the same purpose as the setLocation method. However, the subtle difference between the move method invoked on Qt widgets and the setLocation method invoked on swing components is that it is necessary to set the layout manager to null by invoking the setLayoutNull method on the frame object so as to cause the setLocation method to work properly. Besides, if the setBounce method is not used, as the layout manager is set to null, the setSize method should be used together with the setLocation method. In contrast, after invoking the move method, the setParent method on the Qt widget and passing relevant parameters, there is no further need to invoke anything resembling the setLayoutNull method on the main window object or a frame object in order to show the Qt widget in the window. To a certain extent, the setFont method in Qt differs from the setFont method in Java. It is possible to invoke the setFont method on a Qt widget by passing only the name of the font, such as Arial. In contrast, the 3 parameters name, style and size must all be passed to the font method to invoke it on a swing component such as a global object. To the setStyleSheet method, there are various parameters that can be passed, such as background color, font size, font weight, etc. It should be noted that on one hand, some of these methods overlap with those of the setFont method. On the other hand, all parameters passed to the setStyleSheet method should be a string literal bracketed by double quotes, with each parameter separated by a semicolon. Besides, each parameter should be followed by a colon and a specific value. Like the setFont method in Qt, it is also to pass only one parameter to the setStyleSheet method to invoke it on a Qt widget. As there is neither setBackground method nor the setForeground method to invoke on Qt widgets, it is possible to pass background color, and/or color, with representing the name or the RGB value of the color, to the setStyleSheet method to achieve this purpose. Considering the factors above, I think that the setStyleSheet method is a superset of the setFont method in Qt. After invoking the methods move, setFont, setStyleSheet, setText on each of the 8 Qt widgets and passing relevant parameters, I declared a for loop with an initialization of an int value of the index of I being 0, a condition of I being less than 2, and an iteration of I with the post increment operator ++. In the body of the for loop, I invoked the setFixedSize method on each object of the pushButton array, and the setParent method on each object of the getBox, global, pushButton and createOButton arrays by iterating I. It turns out that an int value of width and an int value of height should be passed to the setFixedSize method. I passed w to the setParent method invoked on each array of Qt widgets. Regarding this statement, the ampersand symbol was used to reference the parent of the main window object. It should be emphasized that instead of the object itself, the reference of the main window object should be passed to the setParent method. After invoking the setParent method on each array of Qt widgets and passing w as the parameter of this method, I invoked the methods setWindowState, setWindowTitle and show on the main window object. If the parameter Qt:"window maximized is passed to the setWindowState method, the window is automatically maximized when the program is compiled and run. This method with this particular parameter is equivalent to the setExtendedState method with the parameter frame.maximized_ both in Java. The setWindowTitle method in Qt is equivalent to the setTitle method in Java. The show method in Qt is equivalent to the setVisibleTrue method in Java. In fact, the show method, which serves the same purpose, is also available in Java, albeit a deprecated one. The automatically generated statement return a.exec was placed at the end of the code snippet of this program. As I have been familiar with the syntax of declaring a variety of swing components and invoking certain methods on them, I quickly familiarized myself with the syntax of declaring Qt widgets and invoking basic methods on these Qt widgets without strenuous effort. It should be noted that as this program involves Qt widget classes, its code snippet cannot be compiled in other IDEs for C++ such as Microsoft Visual Studio. Nevertheless, it turns out that it is possible for Qt Creator to compile a code snippet that can be compiled in other IDEs for C++ such as Microsoft Visual Studio. As creating this program requires the installation of Qt Creator as well as some preliminary knowledge of C++ and Qt, this program might not be a good practice for Java developers. It is also difficult to evaluate whether it is a good practice for intermediate programmers or not. The key points of this program are summarized below. Key points denotes the user-defined name of a Qt widget such as global denotes the name of the font, which is bracketed by double quotes. In the setFont method invoked on the Qt widget denotes the size of the font. In the setFont method invoked on the Qt widget denotes the name of the font style, which follows font and two semicolons. In the setFont method invoked on the Qt widget $denotes the name or the RGB value of the background color. In the setStyleSheet method invoked on the Qt widget $denotes the name or the RGB value of the foreground color. In the setStyleSheet method invoked on the Qt widget $denotes the int value of the font size. In the setStyleSheet method invoked on the Qt widget $denotes the name of the font weight. In the setStyleSheet method invoked on the Qt widget $w denotes the system-defined name of the main window object, which can be replaced with other user-defined names. Move intax, int a, setFont font, setStyleSheet background color, $color, $font size, $px font weight, setParent w.setWindowState Qt:"window maximized, w.setWindowTitle const string, #include main window.h #include #include int main int arg, char argv, application arg, main window w, checkbox 2, global label 2, push button 2, radio button 2, checkbox 0. Move 0, checkbox 0. Set font Arial, checkbox 0. Set StyleSheet background color gray color orange font size : 15 px font weight thin, checkbox 0. Set text first checkbox, checkbox 1. Move 500, 0, checkbox 1. Set font Baskerville, font : extra light, checkbox 1. Set StyleSheet color yellow font size : 20 px, checkbox 1. Set text second checkbox, label 0. Move 50, 100, label 0. Set font Constantia, 25, label 0. Set StyleSheet color green font weight light, label 0. Set text first label, label 1. Move 550, 100, label 1. Set font Georgia, 30, font : normal, label 1. Set StyleSheet color cyan, label 1. Set text second label, push button 0. Move 100, 400, push button 0. Set font Helvetica, 35, font medium, push button 0. Set style sheet color blue, push button 0. Set text first push button 1. Move 600, 400, push button 1. Set font Miss sans serif, 40, font me bold, push button 1. Set style sheet color purple, push button 1. Set text second push button, radio button 0. Move 150, 300, radio button 0. Set font Helvetica, 45, font bold, radio button 0. Set style sheet color RGB 0, 130, 130, radio button 0. Set text first radio button 1. Move 650, 300, radio button 1. Set font Times New Roman, 50, font black, radio button 1. Set style sheet color RGB 145, 70, 255, radio button 1. Set text second radio button 4, and I equals 0 I to I plus plus, push button I. Set fixed size 430, 110, checkbox I. Set parent W, label I. Set parent W, push button I. Set parent W, radio button I. Set parent W, Set window state Qt: window maximized, Set window title my first Qt program, Show, return a.exec.